We are live and continue our solving algorithm problem. So let's check the next one. So the next one is called count the number of houses at certain distance. We are given a positive integers and x and y. In a city, there exist houses numbered 1 to n, connected by n streets. Okay. There is a street connecting the houses, the house number 1, I, with the house numbered I plus 1, with all I is less or equal to 1 and less or equal and minus 1. An additional street connects the house numbered X with the house numbered Y. Okay, so for each k, such as k is greater than 1, and then you need to find the number of pairs of houses such that the minimum number of streets that need to be traveled to reach house 2 from house 1 is k. And we have to return one indexed array result of length n, where street result k represents the number of pairs of houses such that the minimum streets required to reach one house from the other is k. Note that x and y can be equal. Okay, so let's find out. So for example, we have 3, right? So that means that we have 3 houses. 1, 2, 3. And all these houses actually connected by some streets. So we have n houses and n minus 1 streets. And also we have additional connection between 1 and 3. And we should return a result array where each element represents the total number of pairs of houses such that the minimum streets required to reach one house from the other key. So for example, for pair 1 and 2, we can go from house 1 to house 2 directly. For pair 2 and 1, we can go from house 2 to 1. Okay, from 1 to 3, we can go from 1 to 3 directly. And from 3 to 1, also directly. From 2 to 3, we can also go directly. And from 3 to 2, also directly. Okay. About another example, for k equal to 1, okay, and for k equal to 3, for k equal to 4, 1, 3, 1, 2, 1, 2, 3. Okay, we have n houses. Yeah, what does mean k? I'm not sure to understand this, the problem. Okay, so you can give positive integers exist n houses. There is a street connection. The house number I with the house number An additional streaks connects house number x with house. Okay. For each k, you need to find the number of pairs of houses. Oh, okay. So k is actually, yeah, so if we need k equal to 1, this one, yeah, so we can directly travel, like from 1, we can directly travel to 3. Yes, and from 2, yeah, as well. We don't have any k directions, actually. Okay, here we have all these connections. Where we have k2, we can connect 1 to 3, 2 to 4, and vice versa. 3 to 5 and vice versa. So it's already 6. It's one connection. From 4 to 1 and vice versa. And from 2 to 5 and vice versa. Where is it? Yeah. So 1 to 3 and 3 to 1. 1 to 4 and 4 to 1. Yes. 2 to 5 and 5 to 2. And 3 to 5, 5 to 3. Yeah. So that's correct. So we have 8 connections. For 3 connections, for example, we can go 1 to 5 and 5 to 1, right? 4 connections we don't need. Yeah. So okay. So now I think that I understand, but let's think about solutions. So we have all this connection graph. And this additional connection, actually, it creates multiple connections for us. Yeah. So it creates multiple connections for us. And if we have like x, y equal to similar, we actually don't need anything. So we have one connection like 6 times, yeah, 2 times, 4, and with 3 we need, yeah, we have 1 4 and 1 4. Yeah. So here it's very simple one, but this connection, yeah, so our task is actually to build all possible connections. So first of all, I think that if we have n numbers without this additional connection, then we can calculate actually how many connection do we have. So for example, if we have 3 connections, right? So it means that for n minus 1, multiply by 2. Yes. So let's imagine that we have 1, 2, 3. So we have connection like 1 to 2, 2 times, and 2 to 3, 2 times. So in this case, n is equal multiplied by 2. So it will be 2, like it will be 4 in this case. For k equal to 1. Then for k equal to 2, for k equal to 2, we have probably n minus 2 multiplied by 2. So in this case, 1 multiplied by 2, we have 2. Yeah, because we have 1 to 2, 3, and 3 to 1. Okay. And for k equal to 3, we have n minus 3 multiplied by 2. And in this case, it would be 0. Okay. So we can build actually all these connections. And the same for example, when we have n equal to 5, then we have the same, like 4 multiplied by 2, we have 8. 3 multiplied by 2, we have 6. 2 multiplied by 2, we have 4. Y, we have 2, and then 0. Okay. But the problem occurs when we have this additional connection that should reduce some numbers and increase another numbers. So this formula is instead. So let's now calculate additional. So if we have 2 and 4, if we have 2 and 4, so at least we have additional connection for 2 for 1. When we have k equal to 2, when we have k equal to 2, this is more interesting because then we should calculate how much difference we have between y and x. And if we have like 2, and in this case, we can, I think, update our formula. Yeah, we can update our formula. And check how much additional connections we can have. And we have here 2. And then we should decrease another number of connections. Okay, when I'm on 2. I'm thinking now, should I like create like hash map with key? It would be my number, and then I have connections. I have key -1, right connection, key +1 connection, and possible I have key plus x connections, right? So it's it's possible to have 3 connection at some point. And I should actually calculate this number. I think it should exist some math formula. Bradford-Sergi graph prefix sum. Yes, with prefix sum it's understandable. Let's check hints. If there were no additional street connected house x to y, there would be 2 and pairs of house as distance. Yes, so we actually calculated this. Yes. What hint to? The shortest distance between house I and house J, where J is less than I, is along one of these paths. I, J, I, X, Y, X, and J. Okay. Try to change the distance calculated by path to the other path. Okay. Yeah, but this one can we use prefix sum to compute the answer. But how can we use prefix sum? How can we use prefix sum? Tell me, please. Okay, I think that, I don't know even how to use prefix sum here and what to do. Yeah, let's just jump into the solutions. Side error. Okay. Yeah, it's too complicated, I think. This one. Count of pairs. Okay. Understand the problem, we can conclude that there will be one cycle. Group cycle left, right. Calculate the answer for straight line. Okay. Okay. In circle count. Okay, short mouse. Okay. Okay, thank you very much. I think we haven't solved it even. So, bye.